In this video, I will show you the weather demo that is available with an Apama installation. We will import it into a project, show you the project running, and then go back through the different elements that make it work. And finally, you can see the finished output after this analysis. On opening Designer, we want to import the weather demo. You do this by selecting it from the demos and OK the next screen. To allow us to view the project properly, select the restore icon in the top left corner. Now let's run this project with the bottom left icon to give us an idea of what to expect. This will bring up the dashboard associated with the demo, which shows weather readings for various locations. You will see these are continuously updating in the top table. By selecting any of the locations, it will display the location's information in the labels below and also in the trend graph, all of which are updated with any changes. The location text box is also defaulted to whatever location is selected, so you can easily delete it or even add another location. Right, let's stop the project and go back and have a look at what is needed to put something like this together. To fully view the contents of the project, expand it by selecting the glasses icon. You will see we have data view and scenario service bundles which have been added, a dashboard which is our main display, a monitor file which controls the contents of the dashboard, and a default configuration file. Also for this demo, there is a README which goes into some detail on the demo and has some suggested ways to modify it. Let's look at the monitor file that controls the dashboard's data. Firstly, we declare this to be within a package at com.apamademo.weather. We then have two different event definitions, one for adding and deleting locations. I will show you later how we set up listeners for these and what they impact. It is good practice to have separate event definition files, especially when you have more events, but it's not really necessary for this demo. Next, we have our monitor declaration with a sensibly named monitor which is reflected in the file name. It is also good practice to only have one monitor declared within a file. A sequence of initial locations is declared, with the locations variable being what is manipulated throughout the code. Our onload action, which is akin to main in C++, is called when we start. Here we set up and route the data view add definition to define our data view, declaring some field names and corresponding types, and naming it weather, which is what we refer to it throughout to manipulate this data view. Also important is that we have set the key field here to be location, which we will use to filter on for our dashboard. This example firstly clears any existing data view items that existed for weather. We then spawn to a location handler for each of our initial locations that we have, which I will discuss further down. We also set up some exception handlers around the data view and data view items. There are two listeners for the events we declared earlier, which can alter the list of local locations we have, and also if a new one is added, then we spawn to a new location handler for that. The location handler itself must listen for the delete in order to remove that spawned location handler if necessary. Within our handler, it simply generates some random numbers for the temperature, humidity, and visibility, and updates those values in an instance of the data view item for this weather data view and routes that. It also has a 5-second wait listener where it will repeat this random update. As mentioned previously, there is a listener for the delete location event to kill off the spawned handler. Now that we have our monitor set up, in order to make this data available to the dashboard, we must run the project. Now, let's look at the dashboard and discuss the various settings on the components that make this work. We have already mentioned that we want to use the location variable for filtering, so we have added a substitution variable. You can see this by selecting Tools and Variables. The purpose of this dashboard is that the data shown in the table allows us to drill down to a single instance, and this is then populated in various ways in other components on the screen. For example, the temperature label will show corresponding data to the line, or in other words the location selected, and the trend graph displays corresponding trend data for that selected line. To populate the table, the most important property to set is value table. It is attached to an Apama data view with the default correlator selected and the data view item that we set up in the monitor, weather. Remember, unless we are running the correlator, this data view would not be visible here. A semicolon-separated list of field names are populated in display variables, and everything else can remain defaulted. The next property to look at is the drill-down column subs. Select the three dots and you can see each of the variables added and the substitution variable associated with the location. For the labels, they have also been attached to an Apama data view and again the weather data view instance, with the display variables indicating the individual fields. Also, the filter option is populated as follows, linking back to the instance ID in the table. With the trend graph, you must enter the number of trends you wish to show and then attach each trend to the individual field's data that it should represent, as shown here. You also need to set each trend up to show the history in the graph as follows. The location text box is set to be populated by the location variable and also to feed information into that variable for the purposes of the add and delete. The add and delete commands are attached to send an event from the package we declared and with the respective events chosen. And the substitution variable is set under parameters. Remember, add will spawn a new location handler which will generate its own random numbers for the fields, with delete then removing it if required. And that's it. You can now see everything updating on the screen as described. Thanks for watching.